Hello friends, welcome to BMH Learning. This video is about MIC by linear regression. Before we talk about the method, let me remind you what is MIC, or in other words, we say minimum inhibitory concentration. MIC is the lowest, or you can say the minimum concentration of a chemical, in our case an antibiotic, which is able to stop or inhibit the growth of bacteria. So in this tutorial, we are gonna know how can we test the minimum inhibitory concentration by linear regression. So first of all, what is linear regression? It's a statistical analysis method which quantifies the relationship between one or more predictor variables and one outcome variable. Or in other words, it's used when we want to predict the value of a variable based on the value of another variable. So how this is going to be useful when it comes to minimal inhibitory concentration? In order to determine MIC, the bacterial pure culture can be treated with various concentrations of antibiotic, starting from the lowest concentration, and then we increase it. Let's suppose we discovered a new bacterial species and we don't have any idea about how much it's susceptible to antibiotic like streptomycin. Or on the contrary, we can also have a new or unknown antimicrobial agent. In either case, we need to know the MIC. Let's say lowest concentration used is 10 microgram per ml. Then we increase it to 20, then to 30, and then to 40, and this goes on. Once we treat the bacterial culture with the different concentrations of the antibiotic, then we plot the inhibition data of antibiotic using linear regression. Now, depending on the inhibition data and other experimental conditions, we can use several methods to test these different concentrations of the antibiotic, like diffusion methods, in which antibiotic diffuses from a well or a disc which is placed in the agar medium in the Petri plate. And apart from diffusion methods, there are many more other techniques also. So the point is, we got the data regarding how effective the different concentrations of antibiotic are. Now let's make a plot. On x-axis, we have antibiotic concentration, and on the y-axis, we have inhibition data of antibiotic. So on the x-axis, antimicrobial agent concentration is increasing. And let's assume at the lowest concentration of antibiotic, we notice some growth. And as the antibiotic concentration is increased, we observe the growth pattern like this. Now, by looking at these dots, you can say there is some kind of linear relationship. That is, a linear trend line can be drawn. Now, the point at which the trend line meets the x-axis is the estimated MIC of the antibiotic used. Let's assume the estimated MIC is 85 microgram per ml. So, in order to confirm the exact MIC of the antibiotic, we are gonna use a little bit up and low than the estimated MIC. That is, you can use 83 to 87 microgram per ml. And this would surely give us at which exact minimum antibiotic concentration the bacterial growth is completely inhibited. This was all. Thanks for watching.